Alright, here we go. We're going to finish up this lesson. Here we go. We're going to graph. We've got sine, a cosine, and a sine. So first I'm going to start with making the graph of sine. And we're just going to, eventually I'm going to need to go up to 3, so I'm going to label my y-axis 1, 2, 3. And down to -3, and then we are looking at a domain of 0 to 630. So I'm just going to do 90, 180, 270, 360, 450, going up by 90 degrees because it works very nicely with 90 degrees, 630, like that. So there's our graph. And I'm going to start with I'm just going to start by graphing sine of x in blue. So sine of x starts at 0, 0. And then at 90, if you need to use your calculator, you can. The sine of 90 is 1. So when you plug in 90, you get out 1. And then the sine of 180. And then back down to right there, back up, back down, back down. And so here's our graph. As Marty says you want to draw a nice curve. So there it is, there's sine. Now, to do sine of x plus 1, I'll do this one in orange. You just have to vertically shift the graph up 1. So everything just gets shifted up 1 unit. So that's it. Alright, next. Do this one in pink. Now this is cosine. Now cosine starts at a peak. And the amplitude is 3 for this one. So I'm actually going to start at 3. And then you end up going all the way down like this. So if you need to, you could plug it in your calculator. Like you could do 3 times the cosine of 90. Which is 0. Okay, so at 90 we're going to be 0. Or you just kind of understand what's happening. It just goes up and then it goes back down. Thus being a periodic function. So there's that one, and then the last one we'll do in green. Now this is the sine of 2x. And the 2 is technically inside a parentheses, so it kind of does the opposite. If it's inside the parentheses, it's horizontal. And making the number bigger actually makes the period smaller. So the period is 360 over 2. Alright, which is 180. So that means that this goes through a complete cycle by the time it gets to 180. It's gone up, come back down, and then ends at 180. So we basically need to take and do a horizontal compression. So we're going to start it here. Now we're going to go here, and then down to here, and then down to here. Why am I going to 2? Not 2. Sorry. Here, 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 and here. So there's one cycle. You can see the difference between the blue line. The blue line took 360 degrees to make a cycle, whereas the green line took 180 degrees. Now you just continue this process. So there's another cycle. And there's another cycle. And there it goes. So there are my graphs, nicely graphed. All right, next one. This one takes it up a notch, a little bit. It's like that homework question. Find the unknowns of the function. We got a sine x plus d. So our function is a sine x plus d. There's two unknowns that we got to figure out. We got to figure out what a is, and we got to figure out what d is. This is going to be a system of equations. So the point 98, that gives us the equation a sine 90 plus d equals 8. When I plug in 90, I'm going to equal 8. This point, 210 1/2, gives us the equation a sine of 210. When I plug in 210, you're going to get out a half. Now, this all together, sine of 90, we can go up here to the graph actually. The sine of 90, the blue one, is 1. Plug in 90, you're going to get out 1. So this is just 1a plus d equals 8. So we have a plus d equals 8. And then the sine of 210, I don't think we can get this one from the graph. 210 is like here-ish. It's actually a negative a half. You can plug it in your calculator, plug in sine 210 in your calculator, and you end up with negative a half. So this is negative a half a plus d is 1/2. So there we have it. Now we got a system of equations with a and d. As the IB says, this is two equations in a and d. That's the vocabulary they use. There's two equations with a and d. And we can use polysmalt to figure this out. If you do that, you will get 5 and 3. You could have also very easily just subtracted these out, because d minus d subtracts very nicely. So a minus a half of a is 1/2 a, and 8 minus a half is 7.5. So if you do 7.5 divided by 1.5, you do get a equals 5. So either way, you're going to get a equals 5 as the answer, and d is equal to 3. So there you have it. Figured it out. Next, it says find the equation of this line. Okay, so a couple things to point out here. This looks like the axis of symmetry, which is our d. Looks like d is equal to 1. Our amplitude is right here. So it looks like a is also equal to 1. And then our period, it takes 180 degrees for a complete cycle. So the period is 180, which is 360 over b, our b. 360 over b. So now solve for b. Multiply the b over, divide the 180 over, you're going to get 2. So altogether, our equation for sine is a sine bx plus d. So for us, it's just the sine of 2x plus 1. That's what we call that. And then if you really want to check to make sure you got it right, you plug it in your calculator. You set your window to x min 0, x max 360, y min 0, y max 2, and you take a look and see if you got the right answer. Let's just do it real quick because we need to practice. Alright, so in my calculator I've got my plots are off. I'm going to plug in the equation that we just got. So the sine of 2x plus 1. So there it is. Now I'm going to change my window. This is your x's now. My x's on this graph go from 0 to 360. So I'm going to go from 0 to 360, and I'll have tick marks at every 180 degrees. Sure, just like the graph. And then for this one, for the y values, I'm going from 0 to 2, tick marks every one. And let's see how the graph looks. Looks pretty good. I'd say that it looks just about the same for the most part. Okay, last question. Is the average daily sketch the graph in your calculator for 0 to 24. So let's do another graph in our calculator. We're going to go and sketch the graph in our calculator. The equation is 5 cosine 30t, but our calculator uses x. It only does x for our variables. Unless we're in a different mode, we can do t, but that's a whole different thing. So we're on x. We do x's even though it says t. We always graph y and x. Alright, so I'm going to have to change my window. So let's see if we can look at the context of the problem here to figure out a good window for my problem. Daytime temperature, and so our x's are 0 to 24. So we can definitely go x from 0 to 24. Oops, that's not right. 0 to 24. We'll put tick marks every we'll do every two. So it goes by 2s on my graph. The y min and y max, let's take a look. So we're talking about temperatures. The temperature was raised 20, so we're going to be pretty high. And we are in, is this Celsius? I'm not sure. Let's just see what happens. Sometimes you just gotta kind of go for it. So let's go. The min is 0, and let's say the max is 100. So 0 to 100. It's going to be somewhere on there. We can adjust our graph as we need to. So there it is, and you can see my window is not that great. I want to focus in on. I'm going to go to let's say I'm going to go to 50. So I'm going to change this to 50, and I'll be able to see quite a bit more. There, that's not bad. And look at my Y scale here. That's pretty bad actually. So I'm going to go back and change my Y scale to let's do like 10s. There. Now I got tick marks at every 10. These were 2s and these were 10s. Alright, so there we have it. Now we are done with A. It says find the average daytime temperature during May. Okay. So January is 1. So January is 0. So that means we've got February, March, April, May. February is 1, March is 2, April is 3, May is 4. So what I need to go here is do second calc value and 4. I want to know the value at 4. This is May. 17.5. 17.5. Guessing this is Celsius, degrees Celsius. Find the minimum average daily temperature and the month in which it occurred. So the temptation here is to just kind of try to figure out the minimum like this, right about there, the minimum daily temperature. But the better way to do this is to do second calc, and there's a minimum button in here. So you do minimum, and what it says, go to the left of the minimum. Okay, my cursor's already to the left, so I press enter. Now go to the right of the minimum. Press enter, and the minimum is at 6. The minimum is 15. So we have the point 615, which for us, we have January, February, March, April, May, June, and July. So this is July, and the minimum temperature is 15 degrees Celsius. Alright, there you go. So for your homework, this is a larger assignment. It is due on Friday before class, so you have a whole week. And any of these sketches, I want you to do those in your calculator. We need to practice finding our windows, and just graphing in general.